Great. Good morning, gamers, indie devs, experienced software engineers, colleagues, game developers, and enthusiasts who've gathered here today to explore the traditional software engineering processes that coincides with the dynamic, fast-paced world of game development. Welcome to How to Apply the Software Engineering Process to the Game Development Process. My name is Ryan L'Italian. It's my honor and pleasure to talk to you today about the world of developing a game using the structured pipelines of Perforce, Helix Core, Unreal Engine, and the Jetbrains tool suite. Since game development can be, or is it, an art form, I thought it'd be a bit fun to get a bit creative with word choice today. So software can be a bit dry, so let's spice things up a bit. So my name is Ryan L'Italian. I'm the gaming and media and entertainment evangelist for Helix Core. It's a product on the Perforce suite of products. It's a source control product. We also have other tools in that suite, digital creation, project planning and testing, and kind of creating content for game developers. Our product is not just for game developers. It's for semiconductors, software, and companies who really want to care about security and collaboration in the DevOps toolchain. So myself, I've actually been a software developer for 15 plus years. I was tempted by the dark side of sales by one of my friends, and I switched to kind of a solution engineer. But now I'm a evangelist for the game dev industry for Helix Core. So I'm excited to kind of take you what I've learned through the CI/CD, the DevOps mindsets, kind of the build once, deploy everywhere, strong builds, promotions, build once. And so I want to take you kind of what I've learned through DevOps, apply that to the game dev process, and make your pipeline more efficient. So today, we're not merely attendees in the webinar, but explorers embarking on a journey through the digital realms of software and game development. We'll discuss the structured methodologies of the software development lifecycle and dive into the vibrant and imaginative world of game development. Our exploration aims to unveil the tapestry where those two realms connect, where the structured meets the creative, and where the logic blends with imagination. As we embark on this journey together, we'll explore how methodologies, which have been time tested, proven in the software engineering realm, can be beautifully melded into the game development process, creating pipelines that are not only efficient and reliable, but conductive to fostering creativity and innovation. The software development lifecycle, or SDLC for short, has long stood a pillar in the software engineering domain, providing a structured and systematic approach to developing software that is robust, reliable, and user-centric. It is not merely a methodology, but a guiding philosophy that prioritizes quality, user experience, and systematic progression through the stages of planning, analysis, design, development, testing, and deployment. The essence of SDLC is not just in its structured approach, but also in the principles and philosophies that it embodies. Consider the shift left mindset, a philosophy that advocates for integrating and testing early and throughout the development process. It's a principle that ensures that quality is not a destination, but a constant companion throughout the development journey. The steps of the SDLC are planning, analysis, design, development, testing, implementation, and maintenance. It provides developers with clear goal descriptions, ensuring develop objectives and deliverables are not just understood, but embedded in every phase, mitigating the risk of squandering time and resources. With a testing process embedded before merging into the broader source code, it ensures that software is not merely functional, but clearly commented and reviewed. The clear sequential progression through each stage, requiring peer sign-off, ensures rigorous adherence to quality and milestones. The well-architected documentation provides a safeguard, ensuring team member transitions do not derail the project, offering a continuity and consistency in development, even amongst team changes. That old hit by the bus factor. The iterative nature of SDLC, with the stage capable of feeding back into its previous step, facilitates continuous improvements, the CI and the CD, refinement of the project, and moving the needle on what product manager intends to deliver, and that CD part, continuous delivery. Moreover, the comprehensive documentation and structured guidelines ensures that no single team member becomes the linchpin, safeguarding the project against timeline disruptions in the face of personal changes, sustaining a stable and robust journey. It sounds really complicated and boring, but it's actually a really fast iterative process. So the overview of the game development process. So transitioning into the realm of game development, our path takes a distinctive twist, venturing into territories where creativity, imagination, and experimental design come to the forefront. Here, the process, while embodying a structural resemblance to the SDLC, amidst vibrant creativity, artistic expression, and a focus on crafting immersive and engaging player experiences. Game engines like Unity or Unreal Engine are powerhouses in the game development industry. Here becomes our main toolset, enabling developers to create, innovate, and bring life to the world's adventures and experiences that were once confined to the realms of imagination. The engine is not merely a tool, but a conduit through which ideas are transformed into interactive experiences, crafting worlds players can explore, interact, and be immersed in, or just chilling on the couch and zoning out. Concept art is generated, given the scope of world building. Technical artists then generate those art assets, usually in DCC tools, digital content creation, tools like Maya, Houdini, or Blender. Those assets are then stored in a source control system, like Perforce's Helix Core. Unreal game developers then import those assets, manipulate them, create the textures, the materials, the substances, creating the skeletons. And game builds are then generated and distributed to QA testers for thorough playthroughs. After signing off on the gameplay mechanic, level design, or art style, the build is promoted and then built for various platforms like Xbox, PlayStation, or the Switch. This building is not like traditional software, as it requires many heavy-duty build servers, either on-prem or in the cloud. So with the SDLC, there's kind of 7 straight stages. In the game development process, you kind of have 3 main pillars: pre-production, production, and post-production. So as we stand at the crossroads of the SDLC and game development, we witness a landscape where similarities and differences cross over, but are aligned. With both processes, they traverse the stages of planning, design, development, testing. The focus and approach and outcomes diverge, crafting unique pathways through the end-to-end deployment of that artifact. Artifact in software could either be a zip file with a couple source files, or in game development, it's a large executable application that gets burnt to a DVD. In the traditional software development, utilization of Git in a branching model like Git flow orchestrates the development, ensuring features and fixes are isolated, structured, and systematically integrated. Small branches are created to isolate those fixes, usually in text files or small images, making the merge back in quite easy. In contrast, game development with Helix Core navigates content through the streams branching, creating a visual and structured progression of those changes, ensuring builds are not merely structured, but stabilized in quality as they ascend through that development stream up to mainline, through the testing streams, integration streams, and then landing into a release stream. So depending on your team's project's complexity, you might use tools like Unreal Game Sync to help move binaries between Helix Core and maybe an artist's workstation. Since Helix Core is centralized, we rely on one central location to handle who has access to what, allowing tighter restrictions on files, folders, and file types. Let's dive into what that means in the next slide. The required role of source control. Source control emerges as a linchpin in the development journey, acting as that constant throughout that pipeline that ensures stability, reliability, and collaboration through both software and game development. Doesn't matter what you're creating. When we dive into Perforce, we're not merely exploring a tool, but adopting a philosophy where version control is seamlessly integrated at the development environment, enabling real-time collaboration and providing consistent processes of the project at every stage of the pipeline or workflow. Envision the landscape of a game development project. The combination of assets, code bases, binaries, documentations, and versions could easily cascade into chaos without a structured, centralized version control system like Helix Core. I've seen game files being sent over email and Dropbox and Google Drive. So it's all over the place. It becomes then the beacon guiding development process that every asset is tracked, managed, and controlled, safeguarding the integrity and consistency of the project. In a traditional Git project, the marking materials, documentations, or other microservices like authentication or leaderboards and the binaries and artifacts are not usually stored within the same repository or depot on the Helix core side. So Git was initially built for source code, but game developers are trying to make that work with large non-mergeable binaries. Helix core can keep all of those files in one location for easy access. Let's dive into Helix core a bit more. And in this picture here, we're showing that since Helix core is centralized, all of the different types of scale on the global forefront, proxies, edges, replicas, they're all kind of pointing back to one master location. So you can control the flow of data in and out. So as we navigate through the development, source control with Perforce becomes our anchor, providing stability, consistency, and structured management of all of our project assets. Picture the combination of assets, code snippets, and documentation that intertwine to form the tapestry of our game. Helix Core becomes the custodian of that tapestry, ensuring that every weave, every thread, every color remains consistent, traceable, and systematically managed. Tools like Handsoft, which is our project management software, can also assist in the planning of those resources as well. Who wants to check in what and where and when, how? Perforce doesn't merely manage our assets, it facilitates the collaborative harmony among the development team, ensuring that every member can contribute, modify, review, and collaborate while maintaining the integrity and consistency of the project. It's like a symphony where every musician, every instrument, and every note contributes to a harmonious melody, orchestrated and guided by Helix Core, ensuring the melody remains harmonious, synchronized, and true to its intended composition. Helix Core is designed to manage and track assets and project files, ensuring optimal coordination among development teams. It provides centralized management of all digital assets and source code, allowing developers to work on files concurrently by locking files that are checked out, which prevents conflicts and overwrites. As I mentioned earlier, there's not really easy way to merge binary files. So that in order to control that flow of features coming in and out, artists and users can actually check in, lock a file, work on that file, prevent other people from checking files in, which would overwrite, and then check that file back in, following that kind of process. Helix Core facilitates parallel development, code isolation, ensuring various code lines and versions coexist without interference. With capacities to handle large binary assets and files, it's particularly pertinent in game development, where managing large versions of asset files is crucial. There is no file size cap in Helix Core. We don't charge on files or storage uses. Furthermore, Helix Core integrates with CI/CD pipelines and various plugins, such as those for Jetbrains Gamedev IDE's Rider, Jetbrains Build System, TeamCity, Unreal Engine, Unity, and other game engines, enabling seamless, automated, and consistent development workflow. This enables teams to manage changes, control versions, and ensure integrity and reliability of the end product. So in that SDLC, we have planning phases. In this case, concept phases for the game development. So embarking on the planning and concept stage, we set sail into the ocean of creativity and strategic thinking. It is here the seeds of our project are sown, where ideas take the initial steps becoming reality. In this stage, it's imperative that we dive deeper into defining our project scope, carving out clear objectives and giving shape to our initial concepts through mock-ups, storyboards, and prototypes. Imagine the genesis of a game, an idea, initial sketches of characters, gameplay design, and the conception of worlds yet to be explored by future players. The concepts of worlds, characters, and adventures begin to take shape, providing a tangible form of ideas and creativity that will become our game. At this phase, the importance of detailed planning, clear documentation, and establishing coherent, feasible timelines cannot be overstated. It becomes our roadmap, guiding us through the stages of development, ensuring journey is structured and aligned with our objectives. To manage these projects and schedules, teams usually adopt a waterfall or agile planning style. The usual software development tool becomes Atlassian's Jira or Monday or Handsoft, which also has its pros and cons. In the game development pipeline, it's traditionally a waterfall style, where the game design document, the GDD, is referenced continuously, and schedules are planned out with tasks broken down possibly to the hour to hour, where software usually defines tasks as bugs or features, epics, or mountains. Game development's tasks are usually an asset completion, like adding light to a level, or an asset's material that's finalized. Since video games have a stronger deadline than software, as they need to be packaged, built, and deployed, timelines and task management becomes paramount. So in our analysis in the pre-production phases, we transition to the pre-production stage. The roadmap unfurls further. The emphasis pivots towards detailed feasibility analysis, risk assessment, with a sharp focus on finalizing game's design before building, gameplay mechanics, and asset requirements. It's a phase where the abstract begins to take a more defined shape, where envisioned worlds start becoming structured entities, and where ideas are starting to be scrutinized for feasibility, risk, and aligned with objectives. Imagine those crafted characters, designed worlds, and the intended adventures. Now we analyze them through the lens of technical feasibility, user engagement, and development pragmatism. Every character design, game mechanic is dissected, analyzed, validated against the project's scope and timeline, ensuring that we progress further. Our development means aligned, feasible, and true to the concept. Both software and game development pipelines are closely matched here, as planning is paramount. In software, usually an iterative approach works to improve the software to test out new features. It has a tight build test iteration. Game developers and artists will usually create a new project to focus on prototyping out an innovative game mechanic. Since Helix Core can have many depots or repositories in Git language, so depots, that prototype mechanic can live in its own depot away from the main game. It can work in isolation. A benefit to using Helix Core streams is that you can easily import your shared game engine, so you can ensure the mechanic will work when integrating into the mainline stream. I'll go into streams in a little bit, but you can carry code over, import, and we can reference other projects similar in game development as software. Entering into the design and development phases of our process, our concepts begin to team with life, right? The characters, adventures, the worlds, once confined to sketches, concept art, and documentation, begin to materialize, become entities that move, interact, engage with the player. Unreal Engine plays a pivotal role here, providing a platform where core characters, stories, and worlds become tangible and interactive. The live editing view is practically required here to view your changes. This is similar to using Jetbrains Rider to easily code and compile a project. When Unreal Engine assets and Rider code are submitted to Helix Core, a new build can be triggered using our APIs and SDKs to provide testers working with a tangible build. In this domain, code becomes the lifeblood of our project, where efficient, scalable, maintainable code is not a requirement, but a necessity. JetBrains Rider emerges as a valuable companion, offering a platform for efficient coding, debugging, profiling, and ensuring the code base is not merely functional, but optimized, robust, and reliable. Linting tools, in-editor tools, external commands allow engineers to develop and stay focused within their tools to prevent time lost and increase productivity. At the end of the day, you'll need to put your head down and code, develop, put those headphones on, lo-fi girl, and you create beautiful art, well-written code, or the best damn test suite possible. Need to put in those hours, got to grind it out. In order to improve velocity, reduce tedious hours, Helix Core has several integrations to assist and make your life easier. And I'm going to press play on an example. What I have set up here is a P4V, which is our client-side application. I have JetBrains Rider open with my example project, and we have some code, Luke C++ file, and I'm going to kind of take you through the Perforce integration with JetBrains Rider. So I'm going to press play on here. That should work well here. Great. So we have a right click, we have Perforce connected. We're going to edit that file. we're going to make in a really important comment. We're going to save that file. And then we're going to notice how on the pending change list, we have a file on the default change list. So what we're going to do is we're going to try to view that change list. We can make some options here. We can do a difference of the file. So within the tool, you can right click and say compare changes. Great, those are the new changes. That's the code view. We can close that, and then we're going to update the change list description. We're going to make an important change. And notice the hashtag here. We have the skip CI button. Press submit. And now we've got a submitted file. One of the important things about that hashtag was that is an extension that we added to kind of ignore spitting out a build, so that if it's a README change or a documentation change, you don't have to run a full CI build on it. You can kind of skip CI. So. And that was the source code view. So this is the integration of Perforce and Helix Core to make things a little easier. So we've got our Goomba in a Mario type level. We've got Perforce connected to Helix Core. I've already set that one up. And you can right click and say check out. So we've checked out the file using Unreal's integration. We have modified a blueprint on the event tick. We will save that, and we'll go back to view the changes. We've that by default, the files go into the default change list. So we're going to do another submit similar to P4V, but this time we're in Unreal Engine. We're going to move blueprint, and we're going to run a TeamCity build on this. So a hashtag TeamCity. So we've included that as part of our process, submitting that change list and staying in editor. So really kind of automatically kicking off CI, staying in that build, running through that kind of SDLC process, but in the concept of game development. So in this case, what I was just working on was on the development stream. So right in that kind of middle of your screen. So I was working on the development stream and working on let's say a new feature, making Goomba move around. And as kind of code gets merged in, you can visually see how that code flows through your application. As I mentioned, as the SDLC, you kind of shift left. You want to test early. So we're going to be running more tests, faster tests on that development stream using TeamCity. As that code gets more solidified, we're going to promote that content into mainline. And then that's where it merges with other folks' code bases. And then if we're ready to make a deploy, we can actually promote that from mainline into staging. So this is an example. We also have a stream on the right for Unreal Engine. We're referencing the Unreal Engine build in this case, so we're just doing it as an import. And that's a whole different talk. Stay tuned for Unreal Engine training. So we have quite a few integrations, APIs, SDKs. Our software has been around since 1996, give or take. So we've got 30 years of integrations. And a lot of them are open source now. So we can please comment, review. We love Git, we love GitHub. So that's on our GitHub page. It's community driven. We roll those features into our products as well. So as we dive into integrations, SDKs, and plugins, we explore Perforce seamlessly integrates with enhancing and expanding the capabilities of the development environment. Integrations like Helix Core API for various languages and plugins for IDEs serve as bridges connecting our projects to a large number of tools, platforms, and environments, enabling a seamless and efficient development workflow. From triggers to extensions to SDKs, you can create anything the team needs to improve developer velocity. I've heard of customers actually replacing P4V with our APIs and SDKs so that they can control the artist's flow in the artist workstation. Consider Helix Core for Visual Studio or Jetbrains Rider, which facilitates the seamless interaction between the IDE and Helix Core, but enhances the development environment, providing additional functionalities, tools, and capabilities, like I mentioned earlier with that pre-commit hook, development, testing, and deployment processes. It's like having a toolkit that constantly expands to enhance our development journey. A lot of these, if not, are open source on our GitHub page. So please feel free to use, modify, fork, and open pull requests. We'll be happy for any contributions. An example of this is our P4 EXP plugin, which if you look at the context window, it has the Helix Core option, and then you can edit that file. You can check that file in, so you can kind of stay within Windows Explorer. We have all those options as well. So continuing down that SDLC pipeline, we've really kind of focusing on that our game is functional, stable, and performant, but also provides a fun, reliable, and engaging user experience. Here, the concept of shift left testing, which involves integration testing early and often, becomes pivotal, ensuring that quality is embedded throughout the development process. It's not merely a final stage before deployment. Shift left essentially means that you're shifting your tests from the end of the pipeline to early in the process. Essentially, fail faster. If you want to see the problems and see the errors before it's spent building on expensive hardware. So instead of running tests on a staging or release build, you're running tests as part of a continuous integration and delivery workflow. In software, an example would be to run a pre-commit hook to run your JUnit or RSpec tests. In the realm of game development, testing covers more than functionality and logic. Venture into user experience, engagement, immersion. Can you walk through walls? Things like that. Automated testing ensures logical and functional stability, while manual testing ensures that the game provides an engaging, immersive, and seamless user experience. It's a balance between how to run tests on a pre-commit hook, code submissions, stream promotions, or final build deliveries to a build tester. For software, you start with unit testing, a fundamental practice where the smallest conceivable parts of an application, such as functions and procedures, are code reviewed, examined in a collaborative environment, ensuring their optimal functionality, enabling early detection and resolution of those issues. The progress goes into integration testing, which pivots on combining groups units with other services that will combine to make it a more complex project. This path extends into system testing, which is a holistic examination of the entire software's functionality across all scenarios. As you progress through that pipeline, you add more complexity, more services, and more end state testing. For game development, embracing the iterative mindset, developers engage in continuous testing throughout the development cycle, pinpointing and addressing issues in real time, and paving the way for refinements based on feedback loops. The goal of user testing comes into play here. So user acceptance tests, UATs for short, where every facet of the game mechanics, design, art, and player interaction is critically assessed, not to just guarantee usability, but engaging immersive player journey. Compatibility testing takes center stage here to ensure the game performs seamlessly across multiple platforms and multiple devices, getting any hardware hiccups and safeguarding a consistent player experience. Then we dive into performance testing, evaluating the game's test speed, reliability, and resource utilization under varied conditions, ensuring that it not only functions smoothly under peak loads, but also remains stable enough to avoid potential disruptions like latencies, crashes, thus making the gamer happy, which is always a good goal. So one of the examples that we have on our GitHub page is a P4 action. And so you can kind of connect GitHub to Helix Core using GitHub Actions. And in this case, we have a example CI/CD run from our developer, Andy. And that is running integration tests on a code submit that run on small GitHub Action runners that will run your code with a kind of pre-set up environment and respond back with successes and failures. In this case, it's testing Windows, Ubuntu, and Mac. And it's lightweight. It tests kind of code, Node, C++, possibly C++. That's a little different because of the make environment with a Linux machine gets a little more involved. On the game development side, TeamCity has been fantastic to use for myself. So one of the things earlier I mentioned, we did a hashtag with the blueprint, right? So moving the blueprint around on the Goomba. I added a hashtag of TeamCity. So in my build script on TeamCity, I was able to make a regular expression that parses for the changeless description. And whenever I see that changeless description, I will read it and run a build. And so in this case, there's 3 changes ready to be built. And as they were kind of queued up as well to take that on. So that's an integration on the TeamCity side, but that can also add ones to our code review tool, like Helix Swarm. We have that code review tool. We have hashtags and integrations into that, so we can say maybe hashtag review. Maybe on code submission, it generates a new code review on our Helix Swarm product. So it depends on who your team is, how your team is makeup is. Is it mostly artists? Is it mostly developers? Is it a combination of both? So we have all the tools that you need for both sides of that process. So going down that SDLC, we're getting close to the end here on building that project, right? So stepping into that realm of building the project, our focus sharpens on compiling game assets, code, and resources into build versions, intricately crafting platform-specific builds aimed at targeting game deployments. The build force transforms our code from assets and code into individual components into a unified, interactive, and engaging game, ready to be explored and tested. The diverse, complex, numerous assets, code snippets, resources that have been developed or built using workers across workstations, both in and out of the cloud, across various systems and flavors of operating system, Linux, Windows, etc. So that building process becomes a crucible where diverse elements are melded together, forming an interactive build. As TeamCity, as previously shown, emerges as that pivotal tool, automating that build process, ensuring consistency and transformation from a functional build that's consistent and reliable. And I wanted to take a quick second on Tom's 10-minute test. That was a really fun test that I've learned earlier in my software. There's the smoke test and UAT test, but Tom's second test does the application, or in this case game, do all the bare minimum things to make sure that end-to-end process it provides happiness for that gamer or that user, right? Can they sign up? Can they create a widget? Can they move that widget? Can they play, interact? Is that kind of 10-minute test of manually testing this out? Does it pass that test? And I've kind of used that throughout my career as well. And so here's kind of a configuration where we said to that really important change with that Luke C++ file, and it was to skip CI. We didn't need to build it, so it was kind of in this. And we can talk. I think there's another talk by Daniel. We could talk all day about TeamCity build configurations, but that's not for this talk. So great. We're getting close here. So upon reaching the deployment and release processes, our journey nears its culmination. The final game build, having thoroughly developed, tested, and built, now prepares for launch. Development on this is a stage where our game, once confined to just the environment and idea, a sketch, is released into the world, ready to be installed, experienced, and explored by players across the globe. Consider the various platforms, environments, and user bases our game will be released to. The deployment process must ensure that the game is not only accessible, but provides seamless, error-free installations and gameplay experiences across environments. Concurrently, the release processes encompass not only distribution of the game, but also the execution of marketing strategies, user communications, post-release support, implementations, leaderboards, anything external, authorization, ensuring the game is not only played, but experienced, enjoyed, and celebrated amongst the gaming community. Great. So your build was successful. What does that mean? It's not merely an achievement of getting a build through, but it's a testament to the structured, meticulous, and development process following the SDLC. Here we witnessed an amalgamation of structured version control, efficient project management, integrated development environments, automated buildings, testing, seamless asset integration, and dedicated post-release support, converging to make a great game that's not merely a product, but an experience. Reflecting on our journey, we've observed how the implementation of a centralized version control system like Perforce Helix Core, the utilization of Jetbrains Rider for efficient coding and debugging, the establishment of automated build processes with Jetbrains TeamCity, and Unreal Engine to create that experience, all converge to facilitate a development process that's structured, efficient, and quality-centric, using software methodologies that not only improve your game, but your velocity, reduced cost, security, and increase customer happiness. So, arriving at our summary, we've contemplated the journey we've taken today, exploring the myriad of facets of software engineering and game development, weaving through the structured pathways of the SDLC, navigating through the dynamic and creative realms of game development. Our exploration enriched with insights, methodologies, and tools unveils a tapestry where structured methodologies and creative innovations coalesce, crafting a development pipeline that's both structured and innovative. Our journey has revealed how structured methodologies, principles, and tools such as Helix Core, Unreal Engine, and JetBrains can seamlessly integrate into the development process. It enhances reliability, quality, and development process. The final game is not merely a product, but experiences. We have quite a few options for our tools and resources to get learning more. We have 5 free users as part of our default install. We've got Handsoft, which is a project management tool, Helix Swarm, which is a code review and collaboration tool. We've got Helix Dam, which I didn't mention very much. It's kind of that asset review. So Helix Swarm for code review and Helix Dam for asset reviews. Can you see the assets, comment on the assets, go back and forth and track those assets? And we have a relatively new Perforce YouTube channel where we're adding relative new content through how to set up a workspace, how to set up a depot, how to add users, how to create a stream, how to kind of do anything. So we're trying to be that centralized Perforce. So we also did a Gamedev report, and kind of what are some interesting statistics about Unity versus Unreal, on-prem versus cloud, Maya versus Houdini. So it's really interesting to take a look at that. So thank you very much. I can be reached on my email below and on LinkedIn. So I wanted to say thank you, and I really appreciate your time today talking about game development.
Yeah, that was a really, really cool talk. I think the thing I took away from your talk was, you showed us what Perforce can do and what Helix Core can do, and you talked about the technology part of it, but it was really about people, right? You're working in a team, you're trying to facilitate that collaboration that's really important to kind of getting your games out there and feeling confident in them. So these tools are really about bringing people together. And I think that was like a really strong message throughout your entire talk. And I really appreciated that.
And I'm glad that came through. And that's really important. So I remember in 2014, I was working on a DevOps process, and I was just really making it really efficient, really
Mhm.
efficient. It was fantastic. But I went too fast, and it sounds a little, opposite. Why going fast is great, but the culture wasn't ready for it. Right? I did too much too fast, and the team could not catch up on the processes, right? Code meaning 2 thumbs up on a code review, or this person needs to look at it, or how fast does code get into the pipeline? So I think understanding that culture is at a certain size company, culture is the hardest thing to change. Technology
Mhm.
is easy to change.
Yeah, absolutely. It's funny because from a like just development in general and user bases in general, people can only absorb so much change and so much like feature sets, right? Like you can release a game with a million features, but if folks can't literally absorb that much, your game's probably not going to be successful, right? Whereas like your simple casual games can really hit with an audience because they just have such a small absorbable surface area. And I think the same is true for like development processes and just humans in general. So I think you make like an excellent point. I 100% agree with you.
That's great.
Um,
I
yep.
absolutely.
Fader, do you have a question for Ryan?
Yeah, we have a question from Yanni, I think, and he said that I don't think that waterfall model has been a method for a long time, at least not in the mobile space. I haven't heard AAA studios would use waterfall either, or opinions. And so, is there a common style of project management to see your customers using more?
Sure. And one of those things is that we help create the tools, and so people sometimes come to us for how to build a video game, right? So we're a DevOps company, and don't get me wrong, I love helping them and jumping in, but sometimes we don't have a lot of insight into that. But I do know from personal experience that Call of Duty comes out every year, right?
Yeah.
Call of Duty comes out every year, so there is a deadline, there is a date, right? So there is a time based. So it says, okay, well, if you need to deliver on December 1st, if you walk back, it takes a month to develop the build process and testing, and it takes this long. So there are waterfall methods because there is a deadline sometimes to get investor money, right? So in order to ship a prototype or a first pass of your mobile game, there is a deliverable that you need to work towards, a deadline, and that's that crunch factor where sometimes when they set those deadlines so far in advance that they can't hit those, and then they realize, oh, we're behind because we didn't use the proper planning tools, and that we overestimated, underestimated, didn't plan. So it would say waterfall, is not really common in the software development industry anymore. It's still relevant. It's still relevant when you have big trains that need to move, and you have kind of big things that need to deliver. On small mobile games, probably not. You kind of iterative. You kind of work agile, work in smaller deliverables, maybe weekly, bi-weekly deliverables. So AAA's, you start to running into marketing, and release dates. And so I'm still waiting for Black Flag to come out.
Yeah, I'd love a pirate game
Yeah.
around now. So, one of the other things, I think Tiago said this, they felt like stream graphs were really, really important, especially for small and medium-sized devs. Does Perforce have any kind of documentation, video tutorials, or anything like that around really mastering stream graphs?
Sure. And stream graphs here is a feature of Helix Core, right? And so
Mhm.
mastering stream graphs is a double-edged sword, right? So you can master the technology, but how do you master and kind of incorporate our technologies into your pipeline, right? Into your
Mhm.
game dev process. So I've seen teams that just use one mainline, right? Everybody kind of merges in and out, and they kind of use checkouts and locks further if they're flowing traffic. Some companies use a three-step, kind of that what I showed earlier: the development, the mainline, the release. Epic does it. Epic Games does it a different way, right? Other big AAA games do it differently. I was at Unreal Fest last week, and I talked to one game studio, and they are on their 5th version of the stream graph, right? And they've showed us kind of 5 different versions of what that stream graph is. So it really will depend on how your game build process works, how you import engines, how do you kind of work through that process. We do have more YouTube videos coming out soon, so please drop me a line, let us know. And one of those things is we're starting to get feedback from our customers. And I made a joke earlier about we don't make games, but people are coming to us saying, how do I make this game? Where do I put my assets? Where do I put my things? So we're starting to take feedback and starting to pull together um, those ideas and concepts. So please let us know if you found something that works, that doesn't work, if you need assistance. So a lot of us are on the internet web, and we have a support channel as well.
It's funny you make that joke, like you don't build games, but someone in the chat mentioned that you had said Perforce has been around for almost 30 years, and they had asked, how many people watching the stream are actually younger than Perforce and the technology that we provide. So,
Yeah,
don't sell yourself short,
yeah.
because you probably have a lot of institutional knowledge in dealing with a lot of publishers and game
Yes.
developers. So,
Absolutely.
um,
We've learned a couple of things on don't do this and we have just some basics, right? We got some basics, but maybe we're getting into what does a Unity mobile template look like? What is an
mhm,
Unreal Engine, architecture diagram? I use this picture a lot. They're using LED walls, for virtual production using Unreal Engine, right? So what
mhm.
is an example virtual production stream setup and depot setup? So would
Yeah,
love to hear what you're making.
yeah, if I could ever get an invite to one of those spheres or those LED things, I'd love to go to one of those. That'd be
I'm under
awesome.
NDA. I can't help you. Sorry.
um, another thing I noticed, especially when you're showing kind of like TeamCity and GitHub Actions, you were running builds on Mac OS, Ubuntu, Windows. So clearly you're everywhere. Um, with kind of the rise of mobile gaming and Steam Deck, which runs on like a Linux variant, are you seeing that cross-platform like builds and targeting is becoming more and more important in the game industry?
Absolutely. We're getting more questions about Unreal Game Sync and sending binaries to developers' workstations, right? And those workstations being of all different sizes. Usually, Windows kind of is the most popular
Mhm,
environment, but that's kind of the important part that we store the source code on the Helix core side, and we enable the triggers. So once that code is promoted outside and sent to that build server, that's kind of in a different world. We work with other partners like Incredibuild as well to help building out those assets, kind of get those assets faster to more machines to build on more devices. So we can help connect the dots for you, but it's a your mileage may vary on that one.
yeah. Here's another question for you. We're talking about storing code and doing things with Perforce. Clearly, there are teams that maybe start doing their development on Git and you trying to use Git LFS and maybe run into issues with that. I was actually talking to a couple of game devs earlier on Mastodon, and they kind of can't use Git. They just find like the binary management's just not there. Like, what are some ways for folks who are maybe stuck on Git and maybe not liking that experience? How can they transition their projects over to, say, Helix Core?
Yeah, absolutely. And I want to just preface this with we love Git, right? We've got
Mhm,
Helix, Helix for Git, we've got graph depots, we got integrations between both. So we have partnerships with GitHub. There are file size limits. Just fundamentally, it's a decentralized model, right? So Git on the basis is decentralized. You make a copy of a repo and you make the
mhm.
entire copy. So you're making a copy of the game. Some of these AAA games studios, you can't make a copy. It just won't fit on your hard drive, right? So how do you kind of limit what the artist gets to work on? Like if you're working on a tree, a rock, Captain America's shield, right? So you're not pulling the entire project. You're only mapping your content to what you need to work on. If you were in the Git world, you take everything. Right. And
Mhm.
so one of the things, we don't have any file size limitations, or we don't have any, we don't license based on infrastructure. So it's a user base, right? Seat based licensing. So I've been in the Git world for a long time, and Git submodules is really difficult. I always used to screw it up, right? So so we have a thing called stream components. We have that kind of concept, but I would say start looking, investigating. We have a free license, free for 5 to play with it. We've got options across all clouds. We've got Amazon, Microsoft Azure. We've got Google Cloud and DigitalOcean to get started
Mhm.
quickly.
Yeah, and I guess kind of a follow question, like, you can obviously host this stuff on premises, but that comes with like a lot of individuals who have to manage that. Like sometimes you just don't have the resources or the spend to kind of bring in those experts. Is there kind of a hosted model for any of this, any of the things that Perforce offers?
Yeah, and that's kind of one of my main objectives is to make it across all clouds, make it really easy to use in the environment that you are, right? So I had during early COVID, I had a customer call us up and said, "Hey, I'm working on this new sci-fi show. I'm the most technical person here, but I need Perforce, and I don't know what it is. I just need it. I don't know how to run it." And so we started kind of building lots of different options. So we have options for technical artists, ITs, developers, etc. So we've got the enhanced studio pack, which is kind of a best practices cloud formation and Azure ARM templates that'll run infrastructure on your cloud. We've got partners like Assembla to help host some Perforce on their cloud. Kind of a managed service. We've got Helix Remote Admin, which is a white glove service where we will maintain your cloud environment. And then the fun part is we do have a SaaS coming, and it is I can't say the release date yet, but it is coming. We announced it in partnership earlier in the year with Microsoft. So.
Oh, very cool. You said sci-fi show. I'm guessing you're under NDA. You can't tell me anything about that.
Well, I can just say it's Star Trek. I can't tell you anything else.
Oh, okay. All right. That's really cool.
Yeah.
Very, very cool. Fedor, do you have anything else that folks are asking? I see people are asking for my Mastodon handle. I'll put that in the chat. That's not really a question for our guests here,
but I don't think that we have any question left.
Oh, okay. Yeah, I mean, again, this was a great talk. Like the fact is, when you work in teams and you work with tools are really supposed to facilitate the connection between the humans that are there, right? I guess a final question for you, since we're talking about that, and maybe we can end on this. It's like, you start on a small team and a small project, you gain some success. Like, is Perforce something that can kind of grow with you over time? And have you seen that happen to studios that you've worked with?
Absolutely. It's almost it's a knock on wood, but it's a daily occurrence, right? So we had a customer not in the Git environment, but using an SVN, and it was an older project, and they were working on it with, I think it was about 4 or 5 people working on this project. We were talking to them. They were hitting some file size limits and kind of some growing pains because you have to script it, right? You have to script, you have to code around limitations. So get LFS and sub modules and things like that. So we don't have to worry about anything where ours works out of the box. But what happened was that the game prototype went out on Steam, and it was a fantastic hit. It was a fantastic hit, and I have to double check this number, so don't quote me on it. I think they got 100 million in funding or something ridiculous, and to build out this game. And they said, okay, now I have to build it for real. And I know that what I have today doesn't scale. And that we set up our infrastructure and our examples with the hope that the game will succeed. Right. So the only thing you have to do is just add more licenses. So there's no changes. Maybe you add some proxies or replicas across the globe, but those are additive, right? Those aren't changing the way you do game development.
Yeah, and what you described is like every game dev's like dream, right? Like you spend years building this thing, like just sacrificing, putting your energy into it, and you release it, and it's like a mega hit, right? So it's a great problem to have. I think any game dev would welcome that kind of problem. So that's awesome. So yeah, on that note, Ryan, this was a fantastic talk. I loved it. Made me think a lot. Yeah, we really appreciate your time. Anything else you want to maybe kind of remind people where to go to get more Perforce stuff or learn a little bit more? Now's your opportunity.
Yeah, we've got training, Perforce U. It's a kind of a college online course for virtual production, which kind of uses game engines for M&E and the VFX industries. We also have adding more and more content to our YouTube channel. So hit us up with suggestions. I'm floating around Discords, plural, on there. And so, and if you think we need a Perforce branded Discord, let me know. Hit me up in the comments. Smash that like button.
Yeah, that's the life of a YouTuber. You have
to throw it out there. I had to throw it. Smash that like. I had to throw it.
Well, again, thanks so much, Ryan. This was a fantastic talk.
Awesome.
We'd love to have you back. Yeah.
Sounds great. I'm happy to be here. Thanks, folks.
Bye.
Thank you.